My name is Coltin. I'm from the core Android team at Yelp. We're going to talk about continuous integration, mostly with respect to Android, but we'll touch on some things that are not necessarily Android specific. So first, a little bit about Yelp. So our mission is to connect people with great local businesses. For me, that's usually like late night dinner plans when I didn't sort of plan in advance. I want to find a good place to eat. Or sort of more importantly, when I need to get like really good professional services I'm going to spend a lot of money on, so like a plumber or an electrician or a home inspector, Yelp is sort of my go-to place to find that business and spend my money with them. So some numbers that might be kind of interesting about Yelp. So we have 97 million monthly active users on mobile. We also have 115 million reviews across all 32 countries that we currently support. And 74% of our searches are done on mobile. This is sort of emphasize that we're a mobile-focused company, and so building a high-quality Android app is super important to that mission. So first, before we get into CI, I just want to remark that like software engineering is super expensive. In order to get hired, you need to be sourced by someone. You are going to talk to a recruiter and spend time with them. They're going to set up meetings with engineers to do interviews. They might fly you on site. They're going to pay for a hotel and food and all that fun stuff. So that can get pretty expensive. Not alone the fact that you are going to have a salary, you're going to have stock, you're going to have medical and dental and all that fun stuff. PTO days, sick days, office hardware. Your employer's going to pay for electricity and internet. And all this sort of summarizes to the fact that your time is super valuable. The time that you spend working is very important, and you need to make sure that you're spending your time wisely. One thing I like to think about is that the earlier in a process that you catch mistakes, the better. So when you're coding, if you write something and you get told of your mistake right away, say like in Android Studio, that's going to save you a lot of time than if you have to compile and wait a couple of minutes to learn that you misspelled hash map or you didn't capitalize something properly. It's going to cost you a lot, and so it's better to catch these mistakes early. Thinking about the process a little bit bigger, if you wait until production to find issues, you're going to have a rough time, and that you had a whole engineering team work on solving this problem, writing maintainable code, writing tests, and getting everything ready to go. And if you launch this thing to users, and you decide, maybe we shouldn't have written this at all, you now have wasted a ton of resources. You also have this opportunity cost loss where you could have worked on something that's more valuable to your users. So in that instance, if you can solve these problems in the design phase, you're going to save a lot of time and money. So I like to think of things in sort of this like exponential curve of cost. So the sooner you find issues, the better, even before development. So there's this phase where you can save a lot of time and energy by finding issues before development. Then there's this sort of area between where you should start using continuous integration and where you can use other tools to help you save time and money. And then CI is sort of like this defense where you find things before they go out to users. So it might seem kind of weird that I'm here to talk to you about continuous integration, but I'm also telling you that maybe it's not the first thing that you should set up. But there's a lot of things that can save you time and that maybe you should have before you focus on adding CI to your setup. So code reviews is one tool you can use. So you definitely want to make sure that you have some sort of process where you have other engineers reviewing each other's code. You're going to get good knowledge sharing out of this, and you're going to you have sort of a platform to make things happen throughout your process. So we'll talk a little bit about how we use code reviews to enforce things that happen with CI a little bit later in the talk. Static analysis, you can sort of use static analysis to leverage decades of computer science knowledge to find issues that maybe you don't realize are issues before they even surface. And generally, static analysis on your code is going to be super fast. So this is definitely something you should look into. Code style is important. Even if you're working on a project on your own, it's good to have a consistent style that you conform to. That way when you go back and fix things, you're not working with some style you used to use like 6 months ago. So definitely good to have this. And as the slide says, bonus if you have sort of an auto formatter. So at Yelp for our Android team, we use the Google Java code formatter. So we don't worry about how our code's formatted. We just let that handle it. And we no longer talk about this in code reviews, which has been pretty beneficial for us. We'll talk a little bit more about that later. So having good tools, also important. Before you have CI, you should know how your IDE works. So if you find yourself clicking around a lot, that's probably a good sign that you should spend time practicing, maybe 15, 30 minutes a day, making sure that you have a good grasp of your tools. This is sort of going to pay dividends down the road for you. Even if you don't think you're going to use this tool in a couple years, it can be pretty valuable to just understand these patterns that IDEs have that you can apply in the future. So if you know that you can automatically format with like a keystroke, you're going to look for that in your next IDE. So that could be pretty good. One last thing that I'll touch on, and we could probably do this kind of forever. There's a lot of things that you can do to have good development practices, and that's retrospectives. So if you're working on projects and they complete, then you just jump on to the next thing, you're missing like a treasure trove of knowledge for things that you did well, things that you may be able to do better in the future. So definitely recommend sitting down with someone, even if it was a solo project, sort of doing a retrospective to make sure that you learn everything you can out of a project. Okay, so I've been rambling probably for like 5 or 7 minutes about different things, and we haven't even touched on continuous integration or what it is. So we'll sort of start with a definition. So in general, continuous integration is not like server or software that you use. It's a development practice. So you use a shared repository to automate builds, and then you can do some quality assurance on that build. So like running static analysis that we talked about, or running tests, and that's what CI can do for you. That's what CI is. There's also this extension of continuous integration called continuous deployment. So we're not really going to talk about continuous deployment. It is a very valid practice, and people on Android do continuous deployment, though it's a little more rare. You'll commonly see this on web. And basically the idea for continuous deployment is as soon as things pass all your tests and everything, you automatically deploy this to your users straight away. So when you're pushing to master, you're actually pushing to users. So pretty cool. If you find CI interesting, definitely recommend checking out continuous deployment. We're not going to talk about it here, but definitely worth looking into. Cool. Also want to note that continuous integration in general is pretty hard to do and to do right, and especially on Android. So why is it hard, and why is it hard on Android? Emulators can be kind of tricky to work with. So if you're running UI tests, you're going to need emulators, and getting these to work on Jenkins or Circle CI or something can be kind of tricky to get right. Things have gotten a lot better over the last couple of years, especially with the speed improvements for like your regular emulators. You also have multiple options like Genymotion. So things are difficult, but they're also getting better. Tooling has been far from perfect. So it used to be the case that it was very, very hard for us to set up CI. Things have gotten a little bit better where it's easier, and there's more things that are available to get you going. But in general, it's still hard to get things working the way you want. You might have to kludge things together. So having tools be more mature would be helpful, but it's not. Setting up the Android SDK, sometimes kind of hard, even on your own development laptop. Sometimes you just set it up and you try to build the app and it just doesn't work. At least that's our experience at Yelp. Maybe we should fix some things with our setup. But getting this set up on CI can be even more of a challenge, especially when you have to take into consideration that the SDK changes and over time you need to maintain it and keep it updated. And if you don't have an automatic way to do this, this might be kind of a pain, especially if it's split among different nodes. Flaky tests. This is not something that's specific to Android, but if you have a flaky setup for your CI server, it's going to be very difficult for your developers to trust the results that they see. So if something fails, they're not going to think that they're the ones that are responsible for it. They're just going to rerun things or maybe not fix it at all because things are too flaky. And fixing flaky situations, kind of difficult, not always obvious how you can make things work. So this can be a big difficulty when setting up CI. And sort of lastly, if a build fails and it's not clear to your engineers why things have failed, or even if it's just not clear to you, you're going to spend a lot of time going through logs and XML files and different things trying to figure out what happened, when all you want to know is, why did this fail? Was it a test failure? Was it a static analysis failure? Make those things obvious. You need to make things obvious, but it can be kind of tricky to do that. And also notifying people about results. So when something goes bad, how do you notify your engineers that something went wrong? Do you ping everyone on IRC? Do you send out emails? Do you text them? Do you wake them up in pager These things are not necessarily obvious, depending on your situation, and it can be kind of tricky to get this right. So it's something that makes CI kind of hard. So we're going to talk a little bit about Jenkins. If you hate Jenkins, don't worry about it. There's still going to be valuable things in the stock, I hope, for you to take away. But just know that we're going to touch on Jenkins, and if that's a sore spot for you, I'm sorry. Jenkins can be kind of tricky. But also, I'm not here to sell you on Jenkins. There's a lot of offerings out there. Use what works best for your team, explore the options that are available, and you can make the right decision. I'm not going to tell you what to do. Cool. So I think a brief introduction of CI at Yelp will be really helpful. So this will show you sort of our very humble beginnings, and then we'll walk through what we did and where we are today. And I think today we have a pretty good setup, which I'm pretty happy to talk about. So I think this might be useful for people. So the beginning of Yelp was that we created an Android team out of nowhere, and we just needed to ship product really, really quickly. So we were trying desperately to get up to feature parity with iOS and make sure that we had all the things that they had and even more. We were very ambitious, and so shipping very quickly was something that was important to us. The tooling was also hard to set up CI, so it became this really big cost to try and get things set up, and then the aspect of trying to maintain CI to get things to work properly was like kind of expensive for us, so we decided that this wasn't something we wanted to do. Not that that was necessarily the best decision, but that's how things went. Eventually we wanted to start running tests and get CI set up. Basically the rest of Yelp had a very, very mature test-driven development setup, and they ran CI and they did all these great things, and they would always talk about these positive qualities, and we knew as engineers that this was probably the right direction for us to go eventually, so we decided to run tests ourselves. So this was our initial setup. Essentially we had a single Mac Pro that would run everything for us. This was our static analysis, running regular JVM tests, running UI tests, building APKs, everything that we needed, the single Mac Pro did it. We were able to get 4 emulators running on it before we saw diminishing returns. So basically our tests would get slower if we added a 5th or 6th emulator. So 4, for whatever reason, was a magic number. And we were able to use these 4 emulators to shard all of our UI tests. So UI tests can be pretty slow, so we decided to run or split up our set of tests and have them run on each emulator. So this got us some pretty good speeds, and we were pretty happy about this. However, you can only run 1 test suite at a time. So if 3 or 4 people wanted to run the tests at once, they now had to wait for each other. And this was okay at first because, things were pretty fast. And so queuing up wasn't a big deal. Eventually we started adding tests as part of our code review process. So I mentioned before that having code review is very important. And so we were able to leverage this to get people to start writing tests. Because if you just start asking people to write tests, they need to get their feature out. They might not necessarily do it. So leveraging this in code review is really important. So we would ask people not only to run the tests and link to it in their code review, we would also get them to write tests if it made sense for their feature. And people really like doing this. You can sort of imagine that if other people are going to run your tests, you're more incentivized to write tests yourself because you know that people in the future aren't going to come down and break your feature. You need to come in to fix it because you're responsible for it, even though someone else broke it. So this is sort of like this nice symbiosis we could get with engineers to sort of work together a little bit better, even if it's more indirect. Cool. So we got really, really good at writing tests, and our team also started getting a lot bigger. So these 2 things worked in tandem together, and we essentially got test runs that took us 45 to 60 minutes. And as I said, only 1 person can run tests at a time. So if 3 people were in the queue, the last person's not going to see any test results for like 3 hours. And we had a very flaky test run. I sort of talked about how bad flakes can be. If one of your tests flaked, you now had to rerun your tests, and you just hope that, in those 3 hours, nobody else decided to run tests. So this was pretty bad. We realized this long before it got this bad, and we decided that it was time to scale. And this is the architecture that we more or less came up with and that we use today. So essentially we have our Jenkins setup, or your CI setup, using AWS machines to do the majority of our work. So this builds our APKs, this runs our static analysis, and does our regular JVM tests, and we'll touch on these a little bit in the future. And then we use Firebase Test Lab to do all of our emulation needs. So that's basically all of our UI tests. So just to touch a little bit about each of these in a little more detail. So Jenkins handles everything except emulators. And it has basically a split between CPU-heavy AWS machines and RAM-heavy machines. So making the difference between these 2 isn't super important, but it's kind of an optimization you get to make. And we'll sort of talk about what jobs use each of these and why. But if you're setting this up yourself, you don't really need to worry about either of these things necessarily. One thing I wanted to call out about Jenkins, and just about CI in general, is that if you can source control how your builds operate, so what steps need to run, and how each of your different jobs does things, I highly recommend this. So for Jenkins, this is something called the Jenkins Job Builder. You can use this to write YAML files that will describe how your builds run. This gave us a lot of quality in how we actually set up continuous integration. So one issue we had was that we used to run everything through the Jenkins web UI. So essentially what this meant was that anyone could at any time, or anyone who had access could change jobs, and there was no sort of history or record that this was happening, and people would break things without realizing it, and other people would see these failures, and it just was not a good situation. So now we source control everything with the Jenkins Job Builder, and life is a lot better. We can sort of have all the processes we have with writing regular code, and now it's part of how we build CI and how we expand things in the future. It's also a great way to share knowledge. When you make a change, now other people can see how things change. So we've got a lot of value out of source controlling builds. So a little bit about our Firebase Test Lab setup. This is the part that handles all your emulator needs. Getting Firebase Test Lab setup is super easy. Probably if you decide to set up an account and try and get things running, it'll probably take you an hour or so to start running your tests on emulators, which is pretty great. And their documentation is pretty decent. But sharding can take a lot of work. So as I said before, we sharded to these 4 emulators. We sort of took a similar architecture where basically for every test class, and you don't necessarily need to do it this way, but our focus was on speed. For every test class, we start up an emulator. So we run hundreds and hundreds of emulators every time someone wants to run a test suite. And this isn't handled by Firebase Test Lab specifically, and we'll talk a little bit more about that later. But essentially, it's not drag and drop ready, but you can actually do sharding if you want. All right, so what did this architecture get us at the end of the day? So now we have this hard upper limit of 20 minutes to get test results. So regardless of how many people are running tests or how many tests that we've added, you're pretty much guaranteed to get your test results in 20 minutes. You can get them faster in about 9 or 10 minutes, but because of some architecture reasons, a lot of times this ends up being 20. So I'm fairly confident that if we double the number of tests tomorrow, maybe while I'm giving this talk, some interns are working really hard, I'm pretty sure we'll still get 20-minute test results. And also now we can run parallel test runs. So no matter how many engineers are running tests, you can go in and start running your tests. You don't need to wait and queue up behind anyone. You just get to run things right away, which is really nice. So I think it'll be useful to walk through a couple of our Cls responsibilities and sort of the different jobs that we have. So we'll talk a little bit about how we build APKs and get that to scale to multiple machines, running UI tests, something I call checks, which we'll talk a little bit more about, and then a very important job called the merge job. So first, a little caveat. We're going to talk a little bit about Docker in the next couple of slides. If you've never worked with Docker, don't worry too much about that. No need to panic. Docker is a really cool technology. I definitely recommend checking out. Essentially what you need to know for this talk is that it allows you to configure an environment, so something that maybe has an Android SDK or has some software that you need installed, like the Google SDK or something, or the Cloud SDK or something, and then you can take that configuration and copy and paste it onto different machines, and then you're running in that environment. And maybe as we step through examples, it'll make a little bit more sense. Cool, so building APKs is very CPU intensive. So we use AWS machines that have a lot of CPU, but maybe not so much RAM. Although building APKs can take quite a bit of RAM as well. But essentially we focus on using CPU machines. We also build a Docker container that has everything that we need. So this has a lot of different components that are specific to the Yelp setup. We're also considering open sourcing this just as like a small little thing that people can use to build on. But we built ours off of this Uber open source Docker file, which essentially gives you the building blocks to set up your own Docker container. So if you check out this repository, you can use this to start building apps with the Android SDK without having to do any sort of configuration yourself. Then you can kind of add on this to do things that you want that are required for your build. Running tests on Firebase Test Lab for us takes a considerable amount of RAM, and the reason for that is that we kind of as I said before, we try and parallelize everything. So every single test class has its own emulator that's associated with this. And there's no way to tell Firebase Test Lab, at least at this point, like, hey, start up these 300 emulators and chart all my tests to these emulators. We basically have to go to, we basically start up a process for each emulator that we want. We say, here's your test class, please run the APK and test on this emulator, and then we ping it every X number of seconds saying, hey, are you done running our tests? This takes a lot of RAM. It's like 4 megabytes for every test class, so you can see how this explodes really, really fast if your test suite is of any sort of large scale. We also use a Docker file for this. Probably not worth us to even open source this in any way. We basically just use the Google Cloud SDK Docker file, and then we add a little bit of authentication on top of that for our container. So you can just take this and start using Firebase Test Lab. It's pretty simple to do that yourself. Cool, so we have something called the checks job, which is sort of just this amalgamation of a whole bunch of things that we do that are both fast to do and do some pretty important stuff for us. So one thing that we do is use PMD. So this is a static code analyzer for Java files. I don't think PMD really stands for anything. Someone can correct me if I'm wrong about that. I couldn't find a backronym and there was nothing on their website, so it's just called PMD. Find bugs very similar to PMD. They both they cover some of the same area, they find some of the same bugs, but together they find an even larger set of issues that come up. Find bugs differs from PMD, and that does not look at your Java files. It looks at the actual bytecode that is generated from your Java code, which is pretty cool. It'd be fascinating to dig into the details about how that works. But essentially, we use both of these things to find issues before merging code or before putting things up for code review because they run really fast. We also don't find a whole lot of use out of check styles anymore. We used to use it a lot. Basically what this allows you to do is set up rules for how your code should be styled. It's pretty configurable and you can do a ton with it. But now that we automatically format our Java files, it's not so useful for us, but I thought I'd mention it anyways in case you're not willing to automatically format your files or you're not able to for whatever reason. We also do Android lint as part of our checks job, and then also unit tests as well. These are just like a regular fast Java tests. The last job that we'll talk about is our merge job. So this job is pretty important for us. Essentially what it means is that whenever someone pushes to a Git branch that starts with I/, the merge job will look for that and then rebase it on top of master, and then basically run the checks job on top of that. And if that passes and there was no merge conflict or anything, then it will automatically merge your branch into master. It will also close out your code review and comment on it saying, hey, we've merged your code to master, or your release branch doesn't have to be master, it can be an arbitrary branch as well. So this job is pretty simple. It might be kind of tricky about what it's actually giving us, but essentially by introducing this job, no one is allowed to push to master anymore, or they're not allowed to push to release branches. And essentially this has given us a ton of quality on top of master. So it's a pretty rare thing now that our master branch is broken or has broken tests. Other than UI tests, you'll notice that we don't run UI tests just because 20 minutes is a pretty long time. But we will also run UI tests in the future if we're able to get that time down. But getting stability on master is super, super important, especially as your team grows. Even if you only have a couple of developers, if you push something and it breaks the build, but you don't necessarily know it does, maybe it just breaks some tests, and then someone pulls that and is basing their feature off of it, even if you went and fixed it, they don't necessarily know that you fixed it. So now they're in this situation where they go to run tests on their own code, and things are broken, and now they're spending time investigating it and trying to figure out how their code broke this very unrelated test. And they're like really happy that this test broke because unrelated tests are great because it means something really messed up has happened that you want to fix. But really nothing has happened. You just pushed this change on master, and he's now he or she is very upset about this. And as your team grows, this situation and other similar situations happen with more and more frequency. So doing things like this to ensure quality on your master is super important, although this isn't the only thing you can do to do that. Cool, so by working on CI, what are some things that I learned? As I mentioned before, source control your builds. I mean, if I had to get emulators working on AWS machines, I mean, that would probably be a really interesting problem to solve, but it's not something that is necessarily core to what I want to do. So while it would be interesting, definitely has saved a lot of time and reinforces my point that outsourcing infrastructure is really awesome. Cool, so what are some things that maybe I or Yelp is thinking of for Android's continuous integration in the future? Tricking Firebase into supporting sharding would be really nice. Not having to maintain this part of our infrastructure would be great, and we'd probably save a lot of resources and money just having them do it on their side because they're using those resources already. Auto-scaling AWS machines. So right now, our set of machines on Jenkins is fixed, and we scale these up or down manually ourselves. We've only done this once since we introduced this architecture. We probably won't do it for a while, but this would be something that would be nice to auto-scale up and down based on our needs. That way we're saving money. Right now we just have these machines sitting up there consuming money, even though no one is working on those right now. Maybe some people in Hamburg, I don't know. Also detecting flakes and surfacing these better. We don't do a great job of this at Yelp, at least on the Android team. So being able to detect tests that have been flaking frequently and giving developers tools to solve flakes really, really well would go a long way to making our test times not 20 minutes, but maybe 10 minutes instead. And cool, just to summarize, by adding CI, code reviews are a lot nicer. There's also other things that make code reviews nicer that I didn't get into. But essentially by introducing these things that give you quality, we focus code reviews more on like high-level things that are important that engineers need to figure out rather than sort of fussing over code style or trying to get formatting correctly or silly things like that. Just sort of waste our time. Now master is really broken. I just touched on that a lot, but this is super important, especially as your team scales. Definitely want to get that right. Tests, we can scale them out. The number of tests we have and the number of people running tests, we do that portion manually by spinning up more AWS machines. I just want to emphasize that we went in a very short amount of time, probably only 2 or 3 months, from running 4 emulators to running hundreds for every single test suite. And typically we have a lot of people running tests at once, so we're essentially running thousands of emulators at a time, which is quite crazy to think about. I don't know how we do this on our own hardware. But yeah, I just want to call this in because I think that's really, really cool. Awesome, so if you found the content of this talk interesting, highly recommend the Yelp Engineering Twitter account or the engineering blog. I'll be following up with a blog post that sort of details more how you can actually set this up, although I'd be happy to answer any questions from people either here or online if you can find me. Also, if you're looking to make a career change, Yelp is always hiring, probably goes without saying. Cool. Yeah, thanks for your time, and hope you enjoyed the talk.